record to the cloud. That should be on. I think we should be recording. Okay, so just a few things I want to mention. And then actually, instead of giving you guys a long lecture tonight, I'm hoping, how many of you guys are feeling comfortable with the materials from chapter 3? Ions, what they are, things like that. You guys starting to get a handle on chapter 3? Definition of an ion. How would you guys define an ion? A charged particle. So I would define it as a charged particle. And the reason I define it as a charged particle is because there are both monoatomic ions and polyatomic ions. So charged particle, if I call it a charged particle, that's more general than just saying it's a charged atom, because it can be built from multiple atoms that are fused together into a charged particle. You can have a sodium cation, you can have a chlorine anion, but you can also have, like we saw earlier, a phosphate anion. You can have a ammonium cation. You can have a hydronium cation. These things don't have to be single atom particles. They can be multi-atom particles that are fused together. Okay, that's why they're called a charged particle. Now, what is the difference between an atom versus an ion? And in this case, we're talking monoatomic. Is very much that idea of charge. An atom is generally considered neutral. And in that thing, that means, therefore, the number of protons are equal to the number of electrons. In a cation, which we'll define as a positively charged ion, the number of, what I really should say is the number of electrons is less than the number of protons in the nucleus. And an anion is a negatively charged ion where the number of electrons now exceed the number of protons in the nucleus. Now, are there any questions about that? Any questions, guys? All right, if that makes sense, then there's one other thing we need to talk about. In chapter 1, I'm pretty sure you heard the word compound, right? Okay, so a compound will be a substance of more than one element that is also neutral in charge and is a singular unit. And these are things you're familiar with. All right, you have things like Sodium chloride is a compound. It's an ionic compound, meaning that it can be broken apart into ions, and the things that are holding those particles together are ionic charge, ionic forces. You also have things like CO2. This is what we call a molecular, held together by covalent bonds, compound. Okay? The key here is these things, though, are by definition neutral in charge. Okay? And why that is so important is when you talk about a polyatomic ion, these look like, at first, like a molecule, but they are charged particles of more than one atom. Phosphate, great one. Hydronium, another one. Nitrate. There's a whole list of them that you need to know. Any questions? Okay. So that is what an ion is. An ion is a charged substance. Okay. And a charged particle. And again, like I said, anions, negatively charged. So that means the number of electrons exceed the number of protons. Because remember, neutrons are neutral, as the name implies. You cannot change the number of protons in the nucleus, so therefore you have added any anion is negatively charged because it gained electrons. Okay, it gained electrons. You can't lose protons. The only option is to gain electrons. You can't lose protons. That would change the identity of the element. Okay. Any questions so far? Making sense, I hope? Okay. Little crash course in ions and stuff like that. Cations. Positively charged because the number of electrons is less than the number of protons, and this is due to a loss of electrons. Okay? Any questions? All right. From there, a couple of things we need to talk about. There are actually two types. Well, there's a whole different way of looking. There's multiple ways of looking at it, but there's two types of electrons in atoms. There are the valence electrons, which are the electrons in the highest primary shell, highest energy level, These are the electrons that can be removed or added to. They are the electrons that do chemistry. So valence electrons do stuff. If you're not a valence electron, you don't do stuff. You get to be lazy. Okay? Not really, but you get the idea. Electrons don't have feelings or ideas or thoughts that I know of. Don't tell them that. Now, there are also the inner electrons, which are all the electrons in the primary shells beneath the valence shell, which is what we call the highest shell. Okay? So, you've got your highest shell. What does that mean? Well, have you guys looked at valence shells, know what the valence electrons are, understand what that looks like on the periodic table, understand what that looks like in electron configurations? Okay. Yeah, so chromium has an exception, and when it comes to actually valence electrons, it gets even more annoying insofar as much as I've lost my there it is, my laser pointer. So if you look at the periodic table, here's the periodic table right here. The transition metals, they actually fill. So when you're filling electron configurations on the periodic table, you go left to right through the periods, and the highest primary shell works for, so 3, for example, is, you guys may have read now, this is the S block, this is the P block, this is the D block. Okay. This 2, 1, 2, 3, 4, 5, 6, 7, those correspond to the highest primary shell for what we call the primary blocks, which are the S and P blocks. The D block is not a primary block. It is actually, so you fill, when you hit 4, you fill 4S1, 4S2, and then you backfill 3D. This is 3D. You backfill 3D, and then you start filling up 4P. Okay? And the reason I point that out is the valence shell is still 4. So all those 3D electrons that get backfilled aren't valence electrons. Those are inner electrons that are being backfilled, and that has to do with orbital and energy overlap. And I know it's obnoxious, it really is, because I remember learning this back in high school, and my high school teacher was actually a math teacher pretending to teach chemistry. So he didn't actually understand this stuff. He just gave us a diagram to memorize. He never taught us how to use the periodic table. So it's 4S2 and then 4P6. Exactly. You can't, because they are in D, 3D. These are 3D. Exactly. Yeah. Okay. So well, I mean, it's dumb, but it's just how it works, you know. So the electron configuration for krypton is 4s2, 3d10, 4p6, but actually, and that's how you fill it, but it's actually 3d10, 4s2, 4p6 when you're looking at the valence electrons. That's stupid. Okay. Got it? Okay.